Good morning everyone. My name is Charu. I am from Southern University, Surat, and my topic of presentation is synthetic characterization and antimicrobial studies of some novel one for hydrazonium to thalate varieties. First of all, abstract of my work. In the present work, we have synthesized 10 novel 1,3,5 hydrazonium to thalate varieties via 5-step procedures. Structure of all the compounds was characterized by IR as well as NMR spectroscopy and elemental analysis. The newly synthesized compounds were also evaluated for their antibacterial and antifungal activities against some important bacterial and fungal species. Some of the compounds were found effectively active against the bacterial organisms. Introduction. Bacterial compounds are one of the essential class of the phytocytals in various biological as well as synthetic applications. Hydrazonium methanoids have been found to possess various applications in chemistry like pharmaceutical chemistry, polymer industrial agriculture and coordination chemistry. Different F-cycle values have been found to possess various biological applications such as anti-HIV, anti-malarial, antibacterial, antifungal, etc. The combination of extrazine with hydrazole derivatives might be interesting. Therefore, we have used the word general procedures, and melting points are determined by open color method and was found uncorrected. The IR structure was recorded on Siemens FTIR instrument using KBR pellet. NMR structure was recorded on Drupa 2 NMR at 400 MHz using tetramethylphenane as an internal standard and CDCl3 as a solvent. This figure shows the synthetic pathway of compound 680J in which F-cycline was used as a starting material. This was reacted with morpholine at 0 to 5 degrees centigrade for 2 hours in acetone, gives the compound 2. This was monomorpholine derivative. Then it was further treated with morpholine at 30 to 35 degrees centigrade for 2 hours. Gives the compound 3. Compound 3 reacted with hydrogen hydrate at 80 to 90 degrees centigrade in ethanol. Gives compound 4, which is a hydrogen derivative. Compound 4 reaction with carbon disulfide and potassium hydroxide gives the potassium salt of dicarbonate acid. Compound 5 on cyclism with 10 different acid fluoride derivatives gives the final compound 6A2J. These are the procedures of compound 2, 3, 4, 5 and 6 which I have mentioned. Table 1 shows the molecular weight, yield, melting point, element analysis of compound 6A2J. In this I have used different substituents like phenyl, chloromethyl, methyl, 4-nitrophenyl, 2-nitrophenyl, 3-nitrophenyl, 4-methoxy, 3-nitrophenyl, 4-chlorophenyl, 2-chloro-5-nitrophenyl, 4-chloro-3-nitrophenyl. The newly synthesized compounds were characterized by IR as well as H1-NMR. I have mentioned here two NMR and IR first two compounds. The IR sector of the compound was 1560 and 1375 for pH spacing of H-cycline, 1318 for pH of hydrazole, 1110 for morpholine. H1-NMR shows triplets at 3.40 for NCH of morpholine, triplets at 4.05 for OCH of morpholine. The aromatic total shows multiplet at 7.52 to 8.10. The IR spectra of compound 6B shows 2950 and 2884 for methylene 1520 for CN spacing, CN of F-cycline, 1370 and 1315 for CS of hydrazole, 118 for morpholine and 876 for chlorine. H1-NMR shows singlet at 3.0 for CS2, 3.46 for LCH2, 4.14 for morpholine. Antimicrobial activity. All the compounds were evaluated for their antimicrobial activity against some important bacterial as well as fungal species. bacteria S. aureus and S. pyogenes as a gram-positive bacteria and gram-negative bacteria as E. coli and C. aeruginosa, and antifungal activity against C. albicans, A. niger and A. ceratus. The table 2 shows the antibacterial as well as antifungal activity of compound 6-8. Some of the compounds were found moderately active. Compound 6E, 6F, 6G and 6I were found highest active against S. aureus. Compound 6B was found highest active against S. pyogenes. Compound 6C was found highest active against E. coli, and compound 6C and 6D was found highest active against C. aeruginosa in comparison with the standard drug gentamicin. While all the compounds were found moderate to poorly active against fungal species in comparison with the standard drug nystatin. The presence of methyl group at the fifth position of the thiazide will increase the activity against E. coli, C. aeruginosa. All the compounds were found to possess moderate to poor active against the fungal species. Conclusion. Novel substituted 1,3,4-thiazole and 2-thiolates were synthesized from S-triazine in good yield and were characterized by spectral data as well as elemental analysis. Some of the compounds were found effectively active against the tracer organism. This opens the door for the further insertion of this class of compounds, in the particular with the aim of generating valuable data performing the structural activation. I am thankful to Atul Limited, Valsar and Honey Organics for providing some useful chemicals. These are the references which I have used in preparation of this presentation. Thank you. Thank you, Samo. Any questions for Samo?
Yeah, here there's a question.
Sure.
But I thought,
Okay, if you see the inhibitory concentration, the results versus the gentamicin, the inhibitory concentration for the prepared compounds is much higher, maybe 10 to 100-fold higher.
We have
See, it is 0.25 micrograms per ml, and across the range you see it's in hundreds, right?
yes.
So, would you actually, if I ask you your conclusions from your study, would you actually suggest people to take up these structures and work on them?
No, these compounds were found moderately active.
Right, that's what I'm saying. So, did you do any studies which would, improve the potency and bring that dose down? Something which could change that hundreds into 10, which would be very important. Are you understanding what I'm trying to say?
your concentration is very high, she said.
Yeah.
100. You try and bring it down, then it would be very useful.
So, any kind of SAR studies which you have done in your lab, as a part of your work?
No, we have not done assessment.
Because if you see this, the best compound is 6E, if I can see it right. 250.
Yeah.
Right? Rest everything is above that.
Madam, 60, 100.
100?
Equally 60.
Right. But approximately if you see it's
Yeah.
that range. So any modifications from the SAR perspective which could bring down this? Because you must have done SAR on all these, right?
Yeah.
We are not carrying out SAR studies,
No?
only synthetic part.
Only synthesis. The second question is, the addition of the first morpholin ring had a temperature of 0 to 5 as compared to the second one, which is 30 to 35. Why the difference?
Because S-triazine is a symmetrical molecule and the chlorine atom are labile. And the first chlorine atom is placed at 0 to 5 because it gives good yield at 0 to 5 degrees Celsius. And the second chlorine gives 30 to 35 good yield, reflection.
How did you arrive? It is mentioned in
From
the literature
literature,
that 0 to 5.
yeah.
Okay, so nothing happens at room temperature, maybe 20, 25 में कुछ भी नहीं होगा.
No.
No,
If you just put them in a container, nothing will happen.
it is the best condition
For the first morpholin to be substituted.
Madam, cyanuric chloride has this type of property.
It is highly reactive. So
That is why I thought because वो 0 to 5
it should be kept in ice.
हाँ, because
Cyanuric
अगर
chloride.
room temperature पे करेंगे तो दोनों हो जाएंगे क्या नहीं होंगे ना?
नहीं होंगे.
दो मॉर्फोलिन सब्स्टिट्यूशन नहीं होगा. तीसरा भी होता है क्या?
No, no, no. Higher temperature पे होगा.
हायर टेम्परेचर.
Cyanuric has this type of property, madam. And from the literature,
will be the plus.